You have the calculator? Okay.
Seems like they were the
Yeah, that's fine.
Yeah.
Okay, so is there anything anybody wants to discuss about anything from this proofs packet, going up from 1 through 8? Maya?
Other than for the last one, other than like going 1, 2, 3, 4, 5, 6, 7, 8, 9, how do you do that?
Okay, so there's not really any kind of trick to this one. Now, one thing is, you're not going to go, it says if P is a prime number, right? So your counterexample has to have the if part work and the then part not work. So you only bother checking the primes. Does that make sense? Right? Like if you get, like somebody was saying, could you use 4 as a counterexample because 4 is, well, 4 doesn't, 4 makes this not prime, right? 2 to the 4th is 16, minus 1 is 15, but it doesn't work as a counterexample because 4 is not prime, right? So you only have to check the primes. So that's 2, 3, 5, 7, and then 11 is your next one. Somebody told me 13. Did anyone do 13 instead? Somebody was saying 2 to the 13th minus 1 comes out to a number that was more obvious to not be prime than 2047. Like 2047 is kind of an annoying, it's not prime, but it's the product of 2 primes, right? So it's not like it's got tons of factors that you would find right away. Did you do that, Rhea?
Yeah.
What's the number for 2 to the 13th minus 1?
I eventually erased it, but I did do that.
Okay. I think it's like, what did they say it was? Like 81, 81, 8191?
Yeah, but I don't know what the 2 numbers would be.
Oh,
8191, 17, 18, 19. Yeah, somebody said, maybe somebody did it arithmetic wrong, because I think they were saying it was 8181.
It should be 8191.
8191? Okay, 8181, they were saying like 8181, the digits add up to a multiple of 9, so 9's a factor, but maybe they just did the math wrong. I don't know. Okay, there were some people who were a little nervous seeing this, like what if this is on a test and we don't see what it is right away? Well, first of all, you would have a calculator, okay? So like you do not have to figure out that 2487 is not prime or without the aid of a calculator. The other thing is, and some of this is left over from when HL Math had a number theory unit in it, and so there were some things that we were like learning along the way that you guys don't need to know anymore that would make this easier. You guys gotta be quiet here. Like, you don't have to check every number, right? If you want to know does 2047 have any factors, you don't just have to go through like every single number from 1 up to 2047, right? First, like I was saying before, you only have to check the primes, right? Because if it has a factor that's not a prime number, then that factor has prime factors that would be factors of the thing, right? So you only have to bother checking the primes. And you only have to go as high as, you don't even have to go halfway. Do you know how far you have to go before you can say if nothing has worked, it's definitely prime? It's shorter than going halfway.
quarter.
It's not a linear relationship. You only have to go as high as the square root. Do you see why that would make sense? Like if you had a number that was a perfect square, so like you can multiply the square root by itself and get that number. If it's not a perfect square, and there's 2 numbers that multiply to give you it, one of them would have to be lower than the square root, and the other one would have to be higher than the square root. So if you're only looking to see is there a factor somewhere, you only have to check up as high as the square root. If you get all the way through the square root and nothing works, nothing past that is going to work, because if something did, it would have to have a partner lower than the square root to multiply by. Does that make sense? So like the square root of 2048 is a lot lower than 1024, right? And then out of those numbers, you only have to check the primes. So it turns out not to take you that long to check, even if you are going like sequentially in order, because you can skip so much stuff, okay? However, on the test, you can rest assured that I would not, like I don't want you worrying about, this might be like 1 or maybe 2 points at the most, so you should not have to spend like 5 minutes trying to figure out, oh my gosh, is 2047 prime or not. So either, in the context of the test, finding a counterexample should not be hard to do, okay? It would either be some information you've already got in an early part of the problem, or there would be something you've already done in the work that I'm asking you to do that would lead you to it, or it's going to be just obvious to see that there's a counterexample. But you won't have to be just like floundering around, like trying to find a counterexample and looking at case after case where it's not working out, and you're still like trying to find the counterexample, okay? So don't worry about that. Anything else from this packet? Leah?
This is more of like a specific question for number 5.
Okay.
So after I
and then I got 1 over root 3b equals p. And so that would mean that p is not an integer, so would that be like valid to say?
So I did, like where you are is somewhere right around here, right?
Yeah, so
I'm saying a is a multiple of 3, so a is 3m.
Yeah, so instead of doing the next step, I did 3b squared equals 3p squared, and then I got 3b squared equals 9p squared, and then 1 over root 3b equals p. And so then p is not always an integer, so like would I be able to then say that root 3 is irrational?
I think I got a C written out what you're saying once you get to that. So it looks the same as me, like you're gonna say we have a squared equals 3b squared, right?
Yeah.
And a is a multiple of 3, you were using p. So
Oh,
you
yeah.
said a is 3p, so you put 3p in here and got this,
Yes.
and then 9p squared equals 3b squared,
Yes.
and then what?
And then 1 over root 3b equals p.
What are you doing to get there?
Like divide by 9 and then square root. To
P
get
squared is, oh, b squared over 3.
Yeah.
Okay. And now, and then you took the square root?
Yeah. And so then b would not, I mean, no, other way around. Oh, no, yeah, that's right. And then so p would not always be an integer. And because we stated earlier that p is an integer.
So you're saying I'm getting a contradiction right here?
Yeah, I'm saying like, is that a valid contradiction or no?
Aren't you assuming that root 3 is rational?
Oh, right.
What are you assuming?
That root 3 is rational. So it wouldn't be, it'd still be an integer.
Oh, because this would be a fraction. Well, you still don't know. You're going down like a dicey path here when you're dividing with like manipulating integer things, because now it's not true that we don't like, this isn't necessarily a direct contradiction, just like when you're dividing here, just because you're dividing, you're no longer guaranteed to have an integer, but it's not like you're guaranteed that you do not have an integer, right? So that's problematic, right? I don't have a conclusive way to say there's a contradiction here like I do in this argument where I'm saying that like both a and b end up having 3 as a factor.
Yeah.
That's the contradiction.
Okay.
I don't think you can get to, you're not on solid ground here saying, because this appears to not look like an integer. I mean, Miles' point is good here too. Like, if root 3 is rational, which is what we're assuming up to this point, then b over some fraction could be an integer, we don't know. But you can't conclusively say this is not an integer anymore, right? And so, if I don't have a reason to say this is, if I could say for sure this expression definitely didn't come out to an integer, and I already said it was an integer, that would be a legitimate contradiction. But I don't know, based on what I'm assuming so far and where I am here, that this thing is definitely not an integer yet, especially because I'm assuming that root 3 can be written as a fraction at this point, even though we know that's not true.
Okay.
Okay?
Thank you.
That's a good question. All right, anything else from the proofs packet? Jessica? Yeah, did you do a pass?
Yeah.
Okay.
She mocks it.
Yeah, I got you. Okay, is that it? Should we switch to paper 3?
Yes.
Okay. Okay.
You can say all bloggers are beautiful.
Okay. All right, I want to take this a little bit more like step by step because I know people had lots of questions at lots of points on this. And if you notice when you went through this, the early parts are used in the later parts, right? You have to have an understanding of how you got the results in the early part to get the later part. So this one doesn't help as much to like skip around, okay? All right, so let's start here. They gave you this diagram and they want you to show that you have this like inequality relationship here. This expression cosine alpha sine alpha is less than alpha, which is less than sine alpha over cosine alpha. And it says to get to this by considering the area of two triangles and the area of the sector from this thing up here. So there's a couple things we can add to this. I don't like that they didn't label this point. So I'm going to call this S. I don't know why they labeled every other key point here, but they didn't label that one. That's kind of important, right? Because that's the end of the sector, right? These S and P would be points on the circle. This is the unit circle because they told you the radius is 1. So that length is 1. It's also true that from O to S is 1, right? And we can label a couple other things here. They said this is perpendicular, so we have a right angle here. And then they also said that RP is tangent to the circle at P. And do you remember if you have a tangent intersecting a circle at the point of tangency, so if I have the radius and the tangent meeting, what's true there?
You get a reciprocal is a slope.
Yes, because of what kind of angle?
90 degrees.
Right, so the angle here, and I'm talking about the angle OPR, right, the big angle here, that is a right angle. Do you guys remember that from geometry? If you have a tangent and a radius intersecting on a circle, they're always going to meet at a right angle, okay? That's helpful because it's talking about the area of two triangles. One of your triangles is like OPQ, which is a right triangle, and so we can get its area by doing base and height here. But this triangle, the big triangle, OPR, is also a right triangle, so we can get its area with base and height also. We would just use OP as the base and RP as the height. Does that make sense? Okay? So what we want to do, the way to get here is to say the area of the smaller triangle, the one inside the sector, OPQ, is clearly smaller than the area of the sector. But the sector is inside the big triangle. So the biggest thing here is the area of the larger triangle, which would be OPR. Does that make sense? Okay. So the smaller triangle, to get that area, I would like to know how long is OQ and how long is PQ. And you see, because you have, we're going to have expressions in terms of alpha here. In terms of alpha, what's the length of OQ? Remember, the hypotenuse of that is 1, right? So what does the adjacent side have to be? Cosine alpha, right? So this thing right here is cosine alpha. And what's the vertical piece? That thing. Sine alpha. Okay? So the area of that triangle is just 1/2 cosine alpha sine alpha. Does that make sense? Now, what about area of a sector? That's a formula in your packet. If you didn't remember it from, like, when would you have last done this? Like pre-cal, probably? Do you know what area of a sector, how to find area of a sector? 1/2 r squared theta, assuming theta is in radians, which it was given to us as, right? It says up here, theta is between, or alpha is between 0 and pi over 2. So alpha is already in radians, and the radius of the sector is 1. So if it's 1/2 radius squared times the angle, it's just going to be 1/2 alpha. That's the area of the sector. Are we okay there? Okay, and then that area is less than the area of the big triangle. Now the big triangle, we have, let's say, the base, that would be this leg, 1. I need that leg. But remember, I have a right triangle here. I still have alpha in that right triangle. And this time I have 1 acting not as the hypotenuse, it's acting as the adjacent leg, right? So if that's the adjacent leg and this is the opposite leg, what trig function is relevant here? Tan. Tangent alpha would be this over 1. So that makes this length what? Tangent alpha. Okay? So the area of the big triangle, OPR, is just 1/2 1 times tangent alpha, or 1/2 tangent alpha. Are we good there? Now look at what we have, and look at what they want you to get. Do you see it's just like 2 quick manipulations here? What do I need to do? Multiply the 2. Now be careful, when you're dealing with inequalities, sometimes you got to flip the signs, right? When do you do that? Negative. We're multiplying by 2, so we don't care about that. So if I multiply through by 2, I keep the signs the way they are. Cosine alpha sine alpha less than multiply by 2, so this is now just alpha. Less than multiply by 2. This would just be tangent alpha, but tangent alpha can be written as sine over cosine, and that gives us the thing we want. Okay, are we good there? So that's part A. That's 5 of the marks. Okay, B is going to have you use this to show that a certain limit expression, which you guys are familiar with from BC, comes out, but they want you to, sorry. The key is in B there's a hence, right? So that means you're going to use the thing above. So it says, hence show that the limit as alpha goes to 0 of alpha over sine alpha equals 1. You've seen that limit before, or versions of it, right? But the idea is to use what we just did here to show that. So I don't have an alpha over sine alpha expression here, but I do have alpha here. What could I do to this whole thing so that alpha over sine alpha would show up? Divide by sine alpha. Now this is a little trickier than when we just multiplied everything by 2. Now I'm divided by sine alpha. You have to worry about does the inequality sign flip or not. We're dividing by sine alpha. The value of that depends on alpha. We said if you multiply or divide by a negative, you flip the signs, but if it's positive, you don't. Can you tell, do we have enough information here about whether we should be flipping the signs or not? Why, Niall?
Because it's between 0 and pi over 2.
Right, okay, they told you up here that the alpha is between 0 and pi over 2, which means it's in the first quadrant. What do we know about sine all the way through the first quadrant? Positive, so we don't have to flip the signs. Okay? So I'm going to divide everything by sine alpha here. I'm going to write that here. If I divide by sine alpha, the first expression is now just cosine alpha, because I got rid of the sine alpha. In the middle, I now have alpha over sine alpha. And over here, I have sine alpha over cosine alpha, but I'm divided by sine alpha, so that's going to be 1 over cosine alpha. Okay? So based on what we had in A, this is also true, because I just divided by something positive, so all the inequality signs stay. Now, what would happen if I looked at what happened to each of these things as alpha goes to 0? When alpha gets close to 0, what happens to cosine alpha? What does that go to? 1. So that's going to go to 1. There's also a cosine alpha here, so that's going to go to 1. And 1 over 1 is still 1, right? So what you now have is this function that you're interested in is stuck between these other two functions, but both of these functions, as alpha goes to 0, are going to 1. So if we want to take the limit of this, what's the only available value for this thing to have a limit of if it's stuck between two things that are both going to 1? 1.
Good afternoon, students and staff. This is Ms. Deanie, your principal. This is a reminder that at this time in your 6th period class, you should turn on RMBC for a 5-minute spirit video. Please turn on RMBC to view the 5-minute spirit video at this time. Thank you.
All right, I will do that. We will stop here. I just want to make sure that you're getting how we're getting to this, right? These two things mean that limit as alpha goes to 0 of alpha over sine alpha only has one possible value because these two also go there. Francis.
Wait, so would I not have gotten points if I just like...
L'Hopital'd it?
Yeah.
You wouldn't. Do you know why?
Because I didn't do the hence.
Right. That's the only thing, okay? Now, it's only 2 marks here. But those 2 marks, because it said hence, you need this kind of argument to earn those 2 points.
So it says hence, you have to incorporate the thing from the last.
Sometimes IB will write hence or otherwise, blah, blah, blah. That means something up here is helpful to you, but if you don't see that way or you don't want to use it, it's fine. But if it just says hence, then those points are going to be dependent on you having connected it to the thing before. Okay? All right, we'll pick up there Monday. Okay?